Good morning. This is Brian McCarthy from Booz Allen Ventures. I'm the managing partner here. We're here in Sunnyvale, California at Scout AI headquarters. To my left is Collin, Bill, and Randy. They're going to introduce themselves real quick.
I'm Collin Otis. I'm the co-founder and CTO of Scout.
I am Bill Vass, the CTO for Booz Allen.
I'm Randy Yamada, Vice President for Autonomy at Booz Allen.
Thanks, guys, for joining me today. We're going to be talking about the future of autonomy in defense and national security. So, Collin, I'm going to ask you first. You're a multi-time founder and a technologist and somebody who has actually built many different systems. What are you doing with Fury and VLA, and what drove you to focus on the defense and national security arena?
Yeah, what we are doing here at Scout is we really wanted to build a company that is focused on taking the developments of AI systems over the last couple of years and specifically applying that to robotic systems for defense applications only. And so we're a dedicated defense company. What we do is we develop AI foundation models that are able to operate robotic vehicles of different types. So behind us is a form factor of a ground vehicle that we operate. We also have Fury running drones, fixed wings aircraft, missile systems, small ground vehicles, large ground vehicles. And so what we're developing is a camera-based system, end-to-end learned, that is able to understand the world. It's able to understand human speech. It's able to interact with people in a very natural way. And it's able to be trained then to be an expert warfighter. And so the focus of our company is to deliver really a decisive competitive advantage to the U.S. warfighter and make sure that the U.S. is not just on top, but really has a competitive advantage against any adversary as we go into this new world of sort of multimodal, large-scale autonomous systems.
Awesome. Thank you. Bill, you spent 30 years in the industry working at the largest technology firms in the world, as well as in the Department of Defense. What do you think is interesting about their approach to autonomy, and why is autonomy so hard? And generally, what does the Defense Department have to get right here?
Yeah, I think the interesting thing about Scout's approach is this, if you like, world model or visual model they've produced that's an end-to-end autonomy. And there's the two different types of autonomy. There's sort of the transformer autonomy, where you basically took the componentized autonomy and converted the world to 3D and then trained in 3D. They're going directly from the inputs to training this large language model equivalent, right? And that's a new type of autonomy, and it really is speeding up the capabilities in autonomy. And there's a lot of challenges with defense, as opposed to like an ADAS system or something like that in a car. One, you're operating in unpredictable environments. You don't have road lines to stay in and those kinds of things compared to the ADAS systems I work on at, say, AWS and others. You have the challenge of undifferentiated surfaces and things like that, gravel and, sliding in mud and water and all of those kinds of things. I think there's a challenge to make it generalized so it can operate in all these different areas as well. Software-defined autonomy is, usually autonomy is purpose-built for a vehicle, and making a generalized software-defined autonomy, I think, is the future, but it's a challenge there also. And then also operating in radio and GPS-denied environments where the autonomy has to operate independently. So there's a lot of challenges in operating, also the environmental challenges for the vehicle and things like that.
Yeah. Randy, this is your field of expertise. You highly decorated author in terms of the space, worked at DARPA for many, many years, helping them think about their programs. And we're here in Northern California, where you can, call an Uber and get a fully autonomous ride, but that's not really how defense systems work. What are some of the things that you find to be most unique about this job in terms of the atmosphere of like where you have to apply autonomy at the edge use cases, and generally, how are you thinking about kind of the next 10, 20 years of where autonomy needs to go?
Yeah, thanks, Brian. We're entirely focused on mission right now. I think that is the number one eye-opener that we've seen in the last 3 to 5 years, with different technologies being demonstrated on a small scale by competitors, by adversaries, by allies, and by our own warfighters. We've shown that autonomy can be added into these missions to change the way the missions are being done today. So we fast forward even a year, 2 years, 3 years from now, autonomy is going to leak into every mission that we are doing as a nation today. And I think number one for me is the faster we introduce the technology and train our warfighters in how to deploy, autonomy, the most effective way will give us the largest and most decisive advantage.
Yeah. I think it's also cooperative robotics or swarming will be very big. And I think that's going to be an important piece, is the robots being able to swarm and operate. And I think the asymmetric capabilities are also, so a cheap thing causing damage to an expensive thing, that's asymmetric, right? So an inexpensive swarm of drones destroying a multi-million-dollar vehicle or something like that, that's a big challenge. So drone on drone, how to counter drone is a big deal, but also, I think it's going to be an escalating intelligence of autonomy that we're going to have to deal with in these environments.
Yeah, I think one of the things that you guys have both mentioned is around comms denial and GPS denial. And this is where you need true autonomy. You can't have something that is pre-scripted, because the battlefield, to your point, is not pre-scripted. And so you need to be able to deal with a dynamic environment. You need to be able to have periods of time where you understand the commander's intent, and you can really carry that through to a certain point, while still maintaining, I think, Randy, you've brought up a number of times around how do we team these with the warfighter in a way that, still has authorization, and we're still sort of, abiding by principles that are really important. So all of these things, they require true autonomy. And I think what a lot of historically has been developed, for example, it's amazing technology to keep you in between the lanes. It's amazing, but I consider that an automation technology. And I think what the last couple of years of AI systems are bringing us is they're bringing us a higher level of intelligence that allows you to have true autonomy, where you can actually do much larger segments of a mission and use the word leak. I think it's really good. It's starting to leak, and I almost think about it being pervasive over time. So it's going to creep into every part of the mission. And I think as the U.S. really wants to stay on top and sort of keep our position there, it's going to be important for us to be the leader in this space in order to deter those future conflicts, which are going to be low cost, extremely large scale, and the systems are going to be high levels of intelligence, which is what we're already seeing from the adversary.
Yeah, I think one of the things that came up today, I was happy to hear. So I'm a big advocate in distributed systems to be loosely coupled. And in the ISR and command and control environments, in the legacy systems, if you make a change, you have to change everything else that interacts with it. Can you talk about how you're maintaining loose coupling and that dynamic capabilities?
Yeah, and I think this is how we see the world unfolding as well. As the world becomes more, we use the word today, agentic, these are agents that are loosely coupled to other agents. They're coupled, even in a loose sense, to the commander, right, in a way that if you have a severing of a certain communications line, or if a sensor fails, or if I'm no longer able to communicate with the other agents that are out in the field, I should still be able to go to the next action and do that autonomously. And that may be degraded. We might say, a commander might say, hey, if we lose connection, you're no longer authorized to take this action, for example. But when you can build a system that is resilient to all those different things that might happen in a dynamic environment, now you really have a distributed system that has a level of competency where when you lose one or two things, the whole thing doesn't just fall out of the sky and fall apart. And I think that's where we've seen, and we take a lot of the principles, I know all three of us do, we take a lot of the principles that were developed in sort of the resilient cloud computing era, and we try to apply those in this autonomous era. So we view even an agent as having an interface, and that interface you want to be generalized and extensible and resilient, and is there failover, et cetera. So you're basically taking, it's a really exciting time, I think, because you're basically taking, okay, there's all this amazing AI that has been developed for chatbots, and you have real autonomous assets now that are being produced in the United States in the thousands, hundreds of thousands even. And then you have all these principles of resilience and distributed systems and fault tolerance and so on. And you basically have to bring all these things together into what I think will be the largest scale deployment of robots in the world, will be these military applications. And I think then there'll be a huge opportunity to say, okay, now we're doing it, for drones and missiles and ground vehicles, and then what comes next?
I think the other interesting aspect there is that it's not going to be like a single introduction of technology at one time, right? That we are going to constantly have software updates, hardware updates pushed into the field, multiple different types of systems just constantly being introduced. And if you don't have that loose coupling, the whole system is going to fall apart every time.
And you're going to have to be very agile with your models and very agile with training that you've done, because when the adversary figures something else, you need to be able to update immediately to pivot.
And you may not be able to update everything. So if if we basically go do an overnight retraining, we deploy something that can defeat an adversary. We see a new a doctrine, we see a new material, and we're able to sort of be agile, train overnight, deploy something. And if when you deploy that, you only can get it to half the assets, and then they can't talk to the other half of the assets. This is where you really get into this.
There's coupling, and that's where the agents can talk to each other. That they can dynamically bind with each other, which is transformational. That's one of the big advantages of an agentic system.
Yeah, I think one of the things you brought up earlier today, though, is there's a lot of new things here, but then there's also a lot of really hardened systems that you have to bring to bear. So the OTA deployment is one you brought up earlier today. We don't need to resolve that problem. There's a way to basically do OTA,
Secure OTA,
to secure OTA, secure boot. There, a bunch of these things that have already been developed, and then how do you essentially mix and match that? I think that I know you're going to ask about this, but that's what we're excited about the Booz partnership, because there's a lot of really exciting new things that are going on both sides of the house, but you guys have a legacy of really hardened deployment. And how do we take our technology? How do we leverage sort of your levels of expertise and the technology that you already have? And then how do we really accelerate the deployment, adoption, et cetera? And I think the hardened systems is a really important part of that.
When you have 3 experts in the field, I don't even have to actually do anything as a moderator. But I do think it's important that the audience gets a little bit of a taste from the founder's perspective. And so I would love maybe if you could just tell us how you got introduced and how you connected with Colby. And then also, I think it is really important that, there's this 40, 50-year history between the Pentagon and Silicon Valley. Why did you choose to build here? And, we met at AUSA. I remember the coffee a year ago, and we're coming up on that anniversary. And maybe you just give me some highlights and learn lessons over the last year.
Yeah, walk down memory lane. This is fun. So, maybe I'll just actually start from my side. I started my career on the defense side of technology, and so I had an office at NASA Langley, had an office at Air Force Research Lab in Dayton, and those were some of the best times of my life, really, in terms of a career point of view. So, I then spent a bunch of time doing some other things in technology and building some companies and so on. But for me, there's always been this desire to get back to defense. I really, I love the space. I love the warfighter. I love the professionals that work around the warfighter, and the whole the whole sort of industry around it of servants that really are dedicated to the United States and our way, preserving our way of life and defending our way of life. And so I've always loved that side and have always been looking for an opportunity to get back. And so this company is, part of getting back to defense. And that's why we focus 100% on defense is to really build the best thing that we can for the warfighter. The inception of the company, prior to this, I had actually, through another company, I had to start to work on some defense applications for the Army and Army autonomous systems. And at the same time, AI had really started to take off. And when I say AI, I really mean LLMs, VLMs, sort of these higher level of intelligence systems. And so there was a real yearning to get back to defense on a wholehearted basis and really focus on that problem, not build sort of, just the next solution that was needed, but build something that was really revolutionary in terms of giving the warfighter capability and focus on that problem. And at the same time, there's this new technology coming along that says, this solves my biggest problems when I'm trying to deploy to the warfighter, which is I need an autonomous system that doesn't just do segmentation and see leaves and see the ground surface, et cetera, but really understands the scene, understands the environment, can understand interacting with a warfighter, can understand interacting with other agents. And so it was these two things coming together, the new technology that's now available, and then the history that I had on robotic systems and doing that for commercial applications and trying to put these things together and really deliver something for the warfighter. At the same time, I was lucky enough to meet Colby, my co-founder, Colby Adcock,
I've known his brother for a number of years, Brett. He runs a company called Figure, which I consider to be also one of the more exciting companies being built right now around end-to-end learned humanoid robotic systems. So really impressive from a hardware point of view, equally impressive from a vision language action model point of view. And so I'd also spent the last couple of years, getting to watch Brett and getting to see the things that he was building there. And then he introduced me to Colby, and Colby said, "Hey, I want to start a company and I want to start in this space." And we sort of really saw eye to eye on the need to build something specialized for the warfighter. So that was sort of the inception. And
Awesome.
we built the company from there.
And Bill, I know you're, I don't know if you can be considered new to Booz Allen anymore, having been here a year, but I do think it's important to kind of think about, we're investing in these capabilities and companies, and why is that so important for, our 110-year legacy and history? That code of serving has been in our DNA since our first contract with the U.S. Navy in 1945, I think. But why is it so important in this next generation to be, heavily invested in software and hardware as a stack?
My mission is to be first to the future for our warfighters and for our mission partners and for our civilian agencies and for our intelligence agencies and our commercial customers, to really ensure they're first to the future. That's why we started, for example, before Agentic was called Agentic, we built an agent-oriented architecture system and matched for that, and recognized what we started with physical AI before that was a thing. And so it's really important to work with all of these startups in Silicon Valley and other places. Innovation happens everywhere. We're not going to do all of it. And so what we can do is help to bring security foundations, help to bring our mission understanding, our connections that we have in deploying technology, but also our technologists partner with and learn from people like Scout, right? Learn how to deploy their systems, how to extend their systems, and provide feedback as well. So it's a great synergy with all of these companies together with Booz Allen. As we continue our advanced technology capabilities, we've got around 20,000 engineers at the company. About 10,000 of those are involved heavily in software, and I believe that everything's going to be software defined. So I love software defined autonomy. Is going to be across those things, but that also opens up cyber risk. It opens up connectivity risk. It opens a number of things that we have a lot of experience, adversarial AI, for example, mitigating. So we can bring that in addition to help accelerate the startups in these areas also. I was wondering, though, if you used a bit of, as we would call it, alphabet soup, VLM and LLM and end-to-end and those things. Could you, for those who are not versed in those, could you explain what those are and how they're differentiated from, say, what autonomy has been in the past?
Yeah, you bet. So LLM is a large language model. This is essentially a text encoder decoder system. When you're using ChatGPT, that's an LLM. That's sort of the canonical example, or maybe most widespread. So this is a thing that understands human language. Underneath it, understands the concepts of human language. It's able to reason in some sense, and it has what some might call intelligence. So when we think about sort of core AI, artificial intelligence, I think the LLM would be, over the last couple of years, the canonical example of the cutting edge of that, where you can actually understand concepts, you can understand the world, you can understand many different principles of the world by having a very large model that essentially has been trained on all the past human knowledge that has been written down. So that's an LLM. A VLM is a vision language model. So this is a LLM where you attach a vision encoder to the front of it, and that adds the ability to understand imagery and video. And so now you're starting to approach sort of human level system. A human has ears, we can hear, we then sort of have our own, we turn that into text and those concepts and so on, but the eyes are the really important part of us being able to understand the world, for us to be able to reason out the world, and us really being able to learn. A lot of learning is visual. Spatial learning is obviously visual. And this is where it becomes really important when you're looking at robotics. So you take a VLM, this vision language model, and you add what's called an action head on it. So this is essentially, instead of being able to just talk. Now I can grab the controls of a steering wheel and I can turn the steering wheel by a certain amount, and I can do the brake and the throttle, and I can do the sticks of a drone controls, and I can fly a missile with heading speed and altitude. So now you've imbued this system with basically what a human has, which is I have a way to perceive the world, to understand the world visually, audibly, through text, and I have the ability to sort of move my hands around and interact with the world. And so that's what a VLA is
How
that kind of
does
system.
differentiate from a multimodal model and now the new world models?
Yeah, typically most, I would say a very large percentage of the autonomous systems that are out there are more of system automation. So you typically will have some kind of sensing system that is then turned into maybe a 3D representation. You try to see where the shapes are in the world, and then you'll run a next step of the pipeline where you try to predict what's going to happen in the world, and then using those predictions of what's going to happen in the world, you try to run a traditional optimizer or sometimes a learned optimizer that tries to plan trajectories through the world using a more traditional mathematical-based technique. And really the struggle of these systems is each of those submodules gets really good at its component, but it doesn't imbue the system with any level of what we would consider intelligence. And so intelligence really is the ability to understand and generalize to dynamic situations. And that's where these engineered, or we call them sometimes scripted autonomy, because there's really a playbook or script as you have this highly engineered system. They have a really difficult time being truly autonomous because they don't have the level of intelligence that when a sort of edge case, which almost every case that happens in a warfighter environment is an edge case, they don't have the ability to adapt to those or react appropriately to those.
Randy, I want to ask you a mission question. You have hundreds of engineers and researchers who work for you in the autonomy division of Booz Allen that you head up. Lessons learned from Ukraine. Why is mass attritable so important, and what's its application within the context of this conversation?
Yeah, that's fantastic. We're watching technology be introduced, piece by piece. We're watching new tactics and employment methods, and we're still seeing a lot of one-to-one. We're seeing one drone be used for one person. We're seeing it used as a tool that improves, how our warfighters fight and win. And we are starting to see glimpses of what attritable mass can really bring, and how it can overwhelm defenses, about how it can reduce the barrier to use, right? When they're cheaper, that our soldiers are more open to using them regularly, not saving it, and squirreling it away for some time in the future because it's a very expensive thing that can't be used. And so there's an immediate introduction of the technology that we have to get over. People have to understand how to use it, how to maintain it. When you start to multiply that out exponentially and just put, hundreds or thousands of these platforms into the fight, no longer are they going to be controlled by a singular person, right? You can't have one person on the sticks trying to coordinate, 15 different things happening at one time. And so, this technology is incredibly important, not only for or to the development and for its ultimate introduction, but how our warfighters ultimately will use them, right? And change the way how we accomplish the missions by using them in mass.
Yeah. Collin, it's hard not to talk about its application relative to U.S. DoD and U.S. government with a 40-foot by 20-foot US of A flag behind us. But, the White House just released their AI action plan 2 weeks ago. A lot of it talked about making sure that the way we win, and, not to politicize this, but the way we win is to make sure that the infrastructure and the technical stack as AI is deployed in every application is going to be built off the backs of American companies. I think it's very important that, we're in the backyard of all of the companies that are developing all the cutting edge models. When you think about, as a founder, how do we make sure that we advance at a speed and rate to combat China, Russia, et cetera, is applied within, the construct of building your company? Do you think about that from, a talent perspective? Do you think about that from a technical perspective? How do you think about, making sure that American superiority always wins?
Yeah, well, I would say as an overriding principle, the U.S. is an innovation machine. We have the best innovators in the world. And what we're seeing right now is those innovators being applied to the defense problem. And that's what makes it such an exciting time to be starting a company in this space. We are ahead. We are ahead from a personnel point of view. We are ahead from a technology point of view. And the push to really get back to defense. You mentioned Silicon Valley. Silicon Valley started around defense and the needs of defense. And a lot of the technology that has been developed here, including the computing revolution, was developed for defense applications. And so it's just a matter of taking our national skill, the thing that we're better than any other country in the world at, which is rapid innovation. And so I think it's about unleashing the potential of the United States and our people, and really refocusing our efforts on that problem. And that's exactly what's happened. And so I think we couldn't be more excited to be in Silicon Valley. I mean, California has a rich history. A lot of it has moved to Southern California, where a lot of hardware suppliers are. And we see this as a huge opportunity to be in Silicon Valley and be the sort of outlet valve for folks who have the same passion that we do, in terms of looking at this flag and saying, yeah, let's go build this for the protection of the United States, for the protection of our families, for the preservation of our warfighters who are dedicated to the mission here. And so we see ourselves as providing that opportunity for the best AI talent in the world, which is here in Silicon Valley, to come and really dedicate their time to something that means more than maybe some of the applications of AI that might be worked in other places. So, again, just to go back to it, I think we see this as almost like a sort of rebirth of defense in Silicon Valley, and are generally very excited about it. And we have a group of people here, and that group is growing really, really fast, of other people who see eye to eye. So yeah, we feel really lucky to be here.
Gaussian bell curve of talent here that is unmatched for sure.
Yeah, that's right.
Bill, I love how you think through the lens of kind of always leading with cyber first. When you think about autonomy and it's infinite applications, are there enough people talking about how to, bring a cyber first mentality? Because when we talk about some of the use cases in defense, we're talking about GPS denied environments where, EW effects are going to have a massive, effect on this. And obviously our adversaries are extremely well equipped and adept at trying to attack that surface. How do you think about that?
Yeah, I mean, I think my answer to your question is no, there aren't enough people talking about cyber in these environments, because the more, and I'm a huge advocate for software-defined and agentic environments, but the more you adopt it, the more your surface area increases for attack. And we do a lot of work on adversarial AI and how to drift it and corrupt it and change it, and then how to protect against that, obviously. So you got to understand how to do it to protect against it. So, Booz Allen, we have about over 8,000 cyber professionals that really focus on that. But I think that's an area too where we can bring to our partners that capability to help harden while they focus on the innovation necessary for building the system. We can focus on the innovation to help protect the system. But I think I don't think anyone should, that's got to be first. If it's not secure and available, none of the features matter. And the adversary will go after the areas where they can make it unsecure and make it unavailable through that. And then you might have great autonomy, but if it's not working because of a cyber event, then you're in trouble. So I think that's going to continue to be a foundational, really important piece, building it on the right hardware, building it in the right operating systems with the right configurations, using trusted environments, using layered defense in-depth systems, and then leveraging AI as well as part of the cyber defense component, like what we just did with launching Velox Reverser, where it does, and the upcoming products that are around threat hunting and threat detection and threat management and threat mitigation. So I think there's a lot that's going to happen in that space too.
Bill, how do you see development of AI as critical to then protecting against the threats of AI? So
it will. It's going to be the spy versus spy continuous just as it's always been in cyber, where we make a firewall, the bad guys figure out how to get through the firewall. We make a virus scanner, they figure out how to make a polymorphic virus that doesn't show up on the scanner. This is a continuous thing that's been going on for as long as there's been computers, unfortunately. Now, of course, it's used in for economic gain with ransomware and other things like that, and it's used for nation state advancement, stealing intellectual property and cyber attack and other things like that. So it gets to be it's a much more advanced game today, and AI is just going to continue to make it one advantaged in that it can tip and queue and pivot faster based on its experience. So we can train something with 40 years of data on how to fight, but then the bad guys are doing the opposite. They're training 40 years of data on how to attack. And I think that pivot and tipping and queuing is going to be continuous. It's just, there's never going to be something that is secure enough. So you have to balance that.
Randy, I want to ask you one more question and then just do rapid fire, but I think it's important. You've always been a great steward to not only us in the ventures unit, but have always leaned in heavily with a kind of partnering model first. I think it's pretty interesting that we've actually got this natural partnership between us, Scout, and Carnegie Robotics. But how are you thinking about general partnerships and taking these types of startups into your client base, and why is that so important for large institutions and contractors, systems integrators, technologists like us with the best of the startup world?
Yeah, it's an excellent question, and I appreciate we said earlier, Collin, that not all innovation happens in one small kind of locked up box, and so we have to look across the entire industry. We are looking for, and we are focusing on being commercial first, being AI driven and software defined, and we put those three things together to accelerate. And that's the name of the game today. We don't have 15 years to experiment and learn and develop internally, and hire the researchers and kind of build these programs from the get-go. We have to pull things that are incubated in the commercial space, built, and just help get them into the field. And we talked about this a little bit earlier. Just having the technology isn't enough. People have to be trained on how to use the technology. They have to be secured in the right way. That often isn't, made publicly available. How that's done. There's certain aspects of the environment that you have to get used to. Things like being attacked across the electromagnetic spectrum, across the cyber spectrum, GPS denial, and things like that. And so, what we don't want is everybody relearning how to do those things, over and over and over. And so I think when you bring the power of technology that's been incubated again commercially, and companies like ours who have been facilitating, deployment of those technologies, we can really make magic happen.
Collin, maybe last question for you, and then we can wrap it up. When you and Colby started to go out to look and raise your round, what was the most important thing to you about, putting a board together that was, founder first, made sure that the folks that you surrounded yourself around were people who were always going to have your back? And what was it about Booz Allen that attracted you to us coming in your seed round?
Yeah, we want to win. That is a sort of overriding thing, and we look to bring people on board in lots of different faculties, whether that's someone who's joining our team as a full-time employee, someone who's joining as a consultant or contractor, and then one of the most important relationships is who's in the boardroom with us. And so I think one of the things that we recognize was, yes, we're building some new technologies, we're building some new things, but there's no reason for us to go relearn lessons that we can bring people into the most detailed parts of the country or its company. And we don't need to relearn those lessons. And so I think when we sat down with you for the first time, that was really what struck us. Was we had been looking for strategic partners who we could bring in on the cap table and who would be able to help guide us so that we wouldn't have to relearn those lessons while not squashing the things that we're developing internally and not sort of being anti-innovation. And so that was the sort of criteria we were looking for in a partner. And when we sat down at AUSA there, it was incredibly obvious to Colby and I. We walked out of that conversation saying, okay, that's our guy. Like, that's who we want to be with us here and help guide us. And then I think Booz has an incredible reputation as well. So it wasn't, the relationship has been really valuable and really important. Every board meeting that we have, you point out 3 landmines that we can then steer away from, and that is really valuable to us. But then, like we're doing today, you bring this legacy and then the current sort of administration that's at Booz, and it's bench talent that is deep. And so we had a meeting here where we talked about 10 different things, and none of them were new to the team that was at the table on the Booz side. It was, oh yeah, oh great, we worked on that program, or oh great, hey, you know what you need to really watch out for when you're, deploying that way or doing this thing? Oh, and we actually have a piece of hardware that we've already developed for that application that you don't need to go reinvent. And so I think in terms of a strategic partner, we couldn't feel more fortunate in terms of the relationships that we have, and then the depth of experience that gets brought to bear. So
Appreciate that.
yeah, that's how we think about it.
All right, 10-second answer, 2035 prediction for autonomy within the defense and national security space. Anybody got one?
It'll all be about swarms. It'll be about cooperative robotics.
Should have put money on that one.
Yeah.
All Bill does is send me LinkedIn posts about Chinese swarms. So
Yes.
yeah.
It'll be small. It'll be mostly commercial components. There will be, I think, very little military-specific components left in those systems. There'll be, sort of low-cost
In swarms.
small form factor. Yep. Yeah, in swarms. Yeah, that's right.
And the generation that runs them are going to use them in a way I think we don't even know right now.
Yep.
So no more joysticks, no more touchpads. It's going to be something completely different.
Yep.
My prediction is I think we'll have a actual drone force, almost segregated like a space force, because I think that's the future of warfare. Well, thanks, guys. I really appreciate your time.
Yep.
Loved hanging out with you all, and just incredible to learn from all of your experiences.
Thanks for coming, Brian.
Yeah, thank you. Thanks, Brian.